Okay, our next speaker is Craig Emmerich. He's originally from Florida, and he still lives in Florida, hoping to move to North Carolina. He is a survey, and he's going to be talking to us about some work he's doing at a surface mine. He is a vice president of geospatial services with Pickett and Associates LLC, where he oversees planning, execution, and quality control of various aerial, UAS, and terrestrial surveying, mapping projects for a wide range of clients throughout the U.S. and the Caribbean. Craig is a native Floridian and has been involved in surveying in both public and private sectors since 1993, with a focus on airborne LiDAR and imagery since 2012. He's a 2002 graduate of University of Florida's Geomatics program. He is a licensed surveyor in the state of Florida and Alabama with a broad experience in both conventional and aerial surveying. Craig is also a certified wetland delineator. He leverages his expertise in LiDAR, aerial mapping, and surveying to ensure that his clients working in the utility, natural resource, and mining industries receive the highest quality data that can provide insight to complex projects and support data-driven decision-making. What a guy. Here is Craig. Please welcome.
Thank you, Pat. I'm sorry to have to read such a long introduction. And thank you to everybody else here that is hanging out to the very end. I know it's getting late in the conference, so I appreciate that. Again, we're talking about remote sensing technologies for mapping mining sites. I am from Florida, not Montana, so I'm a little bit far from home. Just quickly, who Pickett is. We have been surveying and mapping since 1963. And we also do engineering, but most of our engineering work is geared towards the electrical utility sector. And so, anyway, that's who we are. So Montana versus Florida. I am a little bit far away from home. And yes, Florida does have mines. Y'all have some cool stuff, though. Y'all have the gold, the silver, the copper, the gems. And we have boring stuff like phosphate and lime and sand. But there's still money to be made, right? So up here in Montana, y'all tend to go to the mountains and you dig your mines within the mountains. In Florida, we dig a hole in the ground and then we build our mountains next to it. And so what you'll see on the right-hand side are gypsum stacks. One's been closed, one's still in operation. This is just the byproduct of the phosphate mining industry, or their processes. So the water on top is highly acidic. I've been told that it hovers somewhere around 1, and the pH level is 1. Interesting story about this particular mine. You'll see the pond that's on the kind of the southwest corner of that. They actually had a sinkhole in that several years ago, drained the entire pond. That is, I want to say it's 100 acres and about 50 feet deep, and they have no idea where the water went. They did do a bunch of testing, and the wells around there never found any traces of it. And, we do have karst topography down in Florida where it's just underground caverns that go on and on. We don't even know where they all are. So anyway, the water disappeared, and we still don't know where it went. So what technologies do we use to help the mines in Florida, which could also be used up here? And I'm sure y'all have seen some of this. But one of them is airborne LiDAR and imagery. These are just some different systems that are out there. They all kind of do the same thing. They all, shoot lasers from airplanes. They take pictures from the air. And all of these systems produce about now 4 million points per second. And then there's multiple returns per pulse. Our particular one is the middle one, and we decided to go with that one because we can actually split that up into two systems in two different airplanes, and still 2 million pulses per second is still plenty of data. No matter which system you decide to use, it's all kind of the same. This is just the way it operates. You need to have a ground GPS unit and GPS in the air, so for differential corrections. There's this LiDAR scanner, of course. Different ones. Some oscillate the mirror like ours. Some are on a spinning mirror, but they all spread the laser pulses around. And there's also an inertial measurement unit within the system, so that it's measuring the attitude of the aircraft as you fly through the air. GPS is being measured on a 10 times per second. The IMUs measure in 200 times per second, just to make sure that as you crank through the math, all of that can come out correctly. So what do we do with the LiDAR? Well, we map. We use this LiDAR for the ground portion of the survey. This is part of that same stack. On the left-hand side of the stockpiles, we fly those on a monthly basis for them. That little particular stockpile is kind of cool because they have an underground rail system. That's why you see those divots in the top of the pile. And then this is just a portion of that stack that I showed you earlier. So this allows them to, us to show them the topography. They're also not only regulated with water, they're also regulated with how high they can build these things. And so as they build these things up, subsidence occurs. It's just kind of a process that goes up. So that helps them. We do this on a quarterly basis for them. And of course, there's always pictures. I chose this one because this is actually an older picture. This is that same gypsum stack. The pond that's on the left, kind of the medium-sized pond, that's the one that had the failure and had the sinkhole form underneath it. We take all of this data and we create a Civil 3D surface for them, and that's just because what everybody tends to use. And it comes in just a usable format. The engineers can grab it and run with it because it is a digital surface as opposed to being just a bunch of contour lines with labels on them. So that handles the ground, but now we've got to worry about the water because again, and at least in Florida, and I'm sure this is similar up here, they need to know where all their water is at all the times, which is why we do this on a quarterly basis. So how do you get to the volume of the water? I bring bathymetric LiDAR up only because it is a technology that's out there. The problems that we see with it is all of the suspended material that's within the water will block the light from traveling. I should step back to say, too, that the topographic LiDAR that I was talking about is in the infrared spectrum at 1064 nanometers. I can't remember the wavelength of these, but it's in the green spectrum, and that allows it to penetrate the water. But not only does the sediment that's suspended in the water stop the laser beams from going, these things run about 3.5 times the cost of the other sensors, so there's a lot few of them in the world. So to map the bottom of these ponds and therefore eventually compute the volume of the water for them, there's a couple of different ways we can do it. The way in the past, these pictures are not great, but it gets the idea across. In the past, literally we'd go out there with manual soundings. I've even in the past have tied a railroad spike to a cloth tape and throw it over the measure to measure the depth of it, and you just do that on a regular gridded basis. So that's what the left picture is supposed to show. Then they come out with single beam sounders, just a single beam of sound, and it just gets a really tight line of points on the bottom of the surface. So then we usually run that up and run a grid of points to produce the floor, or the surface of the floor. Oops, sorry. Last but not least, got multi-beam. That will, at least in our system, is 256 sound waves that aim at the floor of the water body, and you can really just paint the bottom of the water body, the floor. It's really nice. What do these things look like? That's a sounder up on top. So that's the one that's the multi-beam. So that's the 256 beams. We use a sound velocity profiler. One is right next to the sounder, and so that's measuring the speed of sound at the surface of the water. And then occasionally we cast another one out into the water and let it go all the way down to the bottom and see what the speed of sound is measuring near the bottom. And we use that to help calibrate the system. We also will do an occasional manual sounding as well to help calibrate the system to make sure we're getting as accurate as data as we can. You can see the construction, or the thing that we've got on the right there. We've developed our own rig to drop this thing down into the water. That pivots back and can be moved from boat to boat. This is it out on the water. It's got 2 GPS antennas, one's for heading and one's for location. The gray box is, you can see a laptop on the left. The gray box on the right is what holds all the brains to the system, so to speak. It has the GPS receivers in it, and it has the control box that lets everything work together, and it also has an inertial measurement unit to measure the attitude of the boat, just like you would in an airplane. And what data do you get out of it? This is the multi-beam data. It's beautiful. This picture is a little bit confusing. I didn't realize it until I got this slide from someone else, and that is the cross section is the white line across the top image, but it's looking down. So the image on the bottom is really kind of reversed. The blue is the low areas, the green and reds are the high areas. Going back to what do you get out of the systems? This is from a single beam, so you can imagine, ignore the dashed gray lines, but if we were just doing single beam and getting just lines of data on a grid, this is the surface that you would get at the bottom of the water body. When we go over to multi-beam, same body of water, now you really get a feel for and a good surface so that you can now compute a more accurate volume of water within this pond. This is another one where it's just a combination. The reds, the yellows, the greens, those are all from airborne LiDAR. The blues and the whites are all from hydrographic or sonar. And this is just another view of what you can achieve once you get it all flown. Everything is geo-referenced, so it all goes together nicely, and you can produce a surface under and above water, and then you can also, the surveyors, when they're out there, will get a measurement, elevation measurement on the top of the water, and we can compute a volume of water for them, for every water body that's on their site. Some of the other ones are the unmanned surface vessels. These are just 4 literally that I found on the internet, because there's so many unmanned systems, both aerial and the surface vessels as well. But prior to the explosion of all these, there's a bunch of them. We came up with our own and developed this with another company. We've actually added to it since this picture. But we are, with this one, we're able to drop a manual sounding down with it being remote. And just with marks on the rope, similar to Brant's presentation the other day. Got marks on the rope so we can count how many feet down we're going. And then again, that helps calibrate the system. But this is a cool little guy. It's a lot slower than doing it with a manned boat, but it keeps us safe, especially in that nasty water. Terrestrial LiDAR is another technology I think could be useful for the mines up here. I think both underground and above ground. Multiple kinds. We actually have the middle one, basically just because it's built tough. It's just it's tough. It can handle most anything. But we use these a lot in electric substations, and then for this particular product, and I don't know what it is, but it's at the phosphate mines, and it's apparently so valuable they keep it in a building. So to gain a volume of that material for them, we use a terrestrial scanner. That's safer than having somebody walk on the pile, and you're also, when you're walking on it, you're going to move. It's just more accurate than making some basic measurements. So we can produce a highly accurate volume for this highly valuable material. Some other applications of this, which we have not done because we're in Florida, is high wall deformation monitoring, just to make sure. I saw at the the sunlight mine the other day, they were using radar and an automatic total station, which I thought was pretty cool. But these could also be used. And then if you had the right survey control, you could georeference and do an underground mine too as well and map that. Everybody's got UAS these days. Again, there's a ton of them. I grabbed a handful of them off the internet. There's all different types. On a normal basis, we use that top left one. A company that we recently merged with, ESP, has bought that bottom left one. It's an octocopter, and they've got a LiDAR system on it. They got fixed wing craft, and then there's these VTOLs, vertical takeoff and landing. I think with the fixed wing, I think the downside is you need room to land and take off. That might not be a problem in Montana because y'all have a lot of wide open spaces I'm seeing. But vertical takeoff and landing is helpful. Most of these carry just cameras, but some of the bigger ones, like the lower left one, can carry a LiDAR system that is survey grade. That one is also a gasoline and a battery hybrid, so they can get about an hour and a half flight off of those. So you can cover a pretty good area with airborne LiDAR on these. What do you get even if you just had cameras? So if you ever heard of the term photogrammetry, it's when you have overlapping imagery. You're looking at the same object from 2 different directions. It creates a parallax. Next thing you know, you can see in 3D. They used to do this manually with this big system, special glasses. They now got what they call soft copy, where it's all digital. And then this is just more of an automated photogrammetry on steroids, where when you take pictures from a UAV, when you're trying to map and make an ortho, you typically with like 70% in lap and 70% side lap, so that you're seeing like a specific feature in at least like 9 images. And so then the software is able to essentially automate that photogrammetry and create a point cloud from just the imagery. And that's what this looks like. And since the point cloud is developed or derived from photos, the RGB values from the individual photos going to be applied to the points, and you have a natural colored point cloud. We did a test a while back with airborne or typical airborne LiDAR, with UAVs with cameras, and with a terrestrial LiDAR. We did it on 4 different stockpiles that were all kind of near each other. Did them all at the same time, so there's no change, and all the volumes came within like less than 1%. So, I mean, all of these are viable technologies to use if you're trying to get a volume or do any kind of mapping. This was just the last one. This is on that same one. stock gyp stack that I showed you earlier. It's just a nice way to monitor. We're flying this one a couple times a week. They've actually pumping down the water on top of this gyp stack because they're worried they may have a tear in the liner. They had seismographs after the sinkhole, so they placed seismographs all over the place. They got some readings they weren't comfortable with. I think they might have had a little bit of a water drop, so they were draining it, and we're doing a monitoring it on a weekly basis and providing them with a photograph at the end, an ortho photo. So these are the technologies that we use to help miners, and that's what I got. Any questions?
Question for Craig. We got one over here.
Oh,
I wanted to know what are the longevity of some of this equipment, and have you experienced any problems with the equipment at any point in time that may have complicated data or messed up any data that you guys have?
so even in the highly acidic water, we don't seem to have an issue with the sounders. The biggest problem that we've had is with boat motors. When we're doing these things on a regular basis, about every 2 to 3 months, we have to replace the propellers. And then even though we flush the engines out, every day after use, we've just got to throw them away after about 1 to 2 years. It just depends because the water just tears them up. But that's the only real thing that we've seen. When you do your calibrate everything correctly, the data's there's no issues with the data. We haven't had any problems with it. Thank you.
More questions? Warren?
Can you talk a little bit more about the use of LiDAR underground in mining? Are the systems portable? I mean, is this something you could use to walk through an abandoned mine, say, and end up with a mine map?
Yep, I can talk a little bit about it. We don't have it only because we don't have underground mines in Florida, so I don't have a lot of experience. But what I have seen in the technology is the terrestrial scanner that I showed, you could do. I know that y'all, a lot of times, will put your control on the roof. So as long as we know where that's at and all that, we could scan everything. You can piece all these scans together and make a three-dimensional map, and it would be geo-referenced for you. They do also have some other items that I think are called SLAM technology with LiDAR, and they're backpack-driven. There's a little unit up on top of you that sticks over your head, and you can literally walk through the mine while you're collecting it. The technology is out there.
We have a question over there.
Yes, ma'am.
Hi, I just had a question on, did you utilize fluorescent dye tracing to study the movement of the acidic water where the sinkhole occurred? Since you mentioned the area is known for karst topography.
I'm sorry, I missed the question. It was hard to hear you.
Oh, it's okay. Did you utilize fluorescent dye tracing to study the movement of the acidic water where the sinkhole occurred? Since you mentioned the area is known for karst topography.
I would not have had been a player in that role, in that part of it, but I think that they did use some dye because they were trying to figure out where the water was going, and so for a time they had just the hole was there, and they built some safety stuff around it, but they were dropping things into that to try to see if they could find the dye come out elsewhere. I don't know that they ever did. Like I said, from what I heard, they don't know where it went. Yeah, you're welcome.
But more questions? All right, thank you very much. Chris.
Thank you, guys.